Okay, we got the second half of this. I'm going to help go through the rest of the problems from homework 8.1. All right, what we have here is again a parallelogram. And if this angle right here is 45 degrees, and they're telling us this angle is 120, here's what I can get you started with. Okay, so this is 120. This entire angle without the diagonal cutting through it. So you can have 60 there. Now, you can figure out the rest of it by yourself. You know that's 45. Figure out what that is. No problem. All right, diagonals. Okay, again, we're trying to teach you about diagonals of a parallelogram. Now, the diagonals don't have to be congruent. They just have to bisect each other. So, those are the same. These are the same. Okay. Now, oftentimes on this problem, I find the mistake of the wrong one being cut in half. Here's what I mean. Okay, so basically, if you have a situation like this, say this is A, B, and C, right? Okay, and let's say we found B is exactly in the middle. So these are the same, right? AB is actually half of AC in this diagram. Why? AC is bigger, right? So you have to take half of it to make it equal to the smaller part. So what I'm trying to explain is most students, if they do mess this up, they will give the half to the wrong one, to the wrong segment. So take a look at this. HN is not half of AD. In fact, they have nothing to do with each other. So that one's out. Okay, they didn't go through this problem. AS is half of AD. That is going to be the one that is the answer. Let me show you. AS is the smaller one, right? AD is the bigger one. So you have to take half of the bigger one to equal the smaller one. Now, usually they don't give this one as the option. That's a pretty weak choice. So usually number one, they'll say something like this. AD being half of AS, right? Now that won't happen because AD is bigger. Taking half of the smaller is not going to make it equal to the bigger, right? That's usually the first choice. Moving on. Little trick here. This is basically giving us an isosceles triangle. So CE and BE. All right. They want you to use base angle theorem. So those angles will be congruent. And ultimately, they want that angle. Okay. So I'm giving you a hint on this. This is a tough problem. Since this is a parallelogram, okay, and you have the measure of angle D is 112. All right. The big concept here is that so is this angle. Opposite angles in a parallelogram are congruent. Now, you can use supplementary angles, linear pair, right? These two are right next to each other. And then what you're left with, you can see what I'm talking about right here. So I'm solving for this angle. So that's 68 degrees. This is isosceles. I'm assuming now you can figure out what that angle is. Okay? So be a little bit careful. With isosceles, these are the legs, right? So the angles across from the legs are equal. This side is considered the base. The base angles are equal. Think, add to 180. You'll finish it off. Number 9, key concept in this one. You want KSO. You want this outside exterior angle. So basically what we have is an exterior angles theorem. Now, this 70 is going to be the same as that one. This 65 they already gave us. To solve for that, one way is to use the exterior angles theorem. Basically add these two together is the same as that. Or add to 180 for the triangle and use linear pair to solve for this one. All right. Proofs. Okay, these ones I will take you a little further with. I'll probably set up the proof and then you can give the reasons. So that's how I'll approach these. All right, as soon as you're given that it's a parallelogram, you're told that it's a given parallelogram, there's a lot of conclusions that you get from that. All right, we have to prove that triangles are congruent. That one's going to be congruent to CDA. We have a reflexive property. That one's going to be easy to share that side. It's probably going to be best. Let's see. Yeah, let's go with, no, I'm not liking any of these. And we could go side, side, side. Yeah, let's go side, side, side. Those sides are going to be congruent as well as those. Okay, so that's probably our quickest method, is to go side, side, side. There's plenty of other ways, but I was thinking through, we're going to need alternate interior angles. We're going to need a lot of things to happen to use any of the angle theorems. So let's go side, side, side. All right, first, I am going to start with ABCD is a parallelogram. That's my first statement. Now, that's given. So go ahead and write the reason over here. Okay, so you'll fill in the reasons on your own. These are going to be, the statements. I'll make those for you. All right, number 2. I'm going to say that AB is congruent to CD, and we're going to use the same reason. So AB is congruent to, oops, I already did AB. AD is what I meant. It's going to be congruent to BC. And I will help you with that one because it's new. Opposite sides of a parallelogram. Now be careful, this one oftentimes gets messed up. We'll have students say parallel. That's true, but we wanted to say congruent, so you got to make sure you say are congruent. Got to make sure that your reason follows what you're trying to say in your statement. A little bit tricky on proofs. All right. 3. All we have left now is AC congruent to AC. I probably should have switched that around, but not a big deal. That is by, you know that one, reflexive property. And then number 4, the triangles are going to be congruent. Probably didn't need to give you that because it is the last statement. And you all know the last statement has to be what we're trying to prove. So good enough, you can finish it off. All right. Let's see. First, we're going to prove that these are in fact congruent. Okay, so we have these triangles right here. Could use the diagonals bisect each other. I'm going to use something slightly different this time. All right, let's use, those are going to be congruent and parallel. So we'll go let's go with, it looks like it's going to be angling to side the way I'm going to do it. Okay, again, I will write statements and you can write the reasons. All right, so here goes. So first, I will start with ABCD as a parallelogram. And you can say that's because it is given. Okay, for me, second statement, I'm going to use properties of parallelogram. So AB is, first, it's congruent to CD, and it's also parallel. Now, this is new to you guys, so I'll do this one. Okay, opposite sides of a parallelogram are parallel and congruent. Oops. So that gets me it gets me the S. and it sets me up to get an A, which I'm going to get next by alternate interior angle. Please just number them for your sake. I'm going to write the 3-letter path, but I prefer if you guys number them. Just make up a number. Just call it 1 and 2. Okay, but I'm not going to do that. So angle ABE is going to be congruent to angle CDE. I'm going to let you guys fill that in. I'm also going to let you fill in the reason for the next one. I'm going to say angle BEA is congruent to angle DEC. Angle BEA congruent to angle DEC. You can fill in the reason for that. And that should be enough. That was a pair of sides right here. Yep. So we have proven the triangle's congruent. You can finish it off. There is one more statement, but you don't need my help with that. Okay, describe a single rigid motion. This could be a point reflection. A would map to C, right? Point reflection. Point reflect, triangle AED, through point E to map onto triangle CEB. Now that'll work because they are in fact congruent now. Okay. And that'll be it for this one. I'll upload another video to finish it off.